everyone, we are excited to show you our CPU scheduling simulator. It's a fun and interactive way to understand how an operating system manages several processes at once to keep the CPU running efficiently. Before we look at our algorithm, it's important to understand that there are two main types of scheduling. First, preemptive scheduling. This means a running process can be paused if more important or shorter process arrive. And second, non-preemptive scheduling. In this, once a process starts, it keeps running until it finishes without any interruption. Now let's see how these ideas work in practice. First, we have first come first serve or FCFS. It's a non-preemptive algorithm where processes are executed in the order they arrive, just like people waiting in a queue. Next, we have shortest job first or SJF. This can be either preemptive or non-preemptive. Here, the process with shortest burst time runs next, which helps to reduce the average waiting time. However, it does require knowing in advance how long each process will take. Now, moving on to priority scheduling. Each process is given a priority, and the CPU runs the one with high priority first. It can be preemptive or non preemptive, but sometimes lower priority processes have to wait longer. Finally, we have round robin scheduling. Here, each process gets a fixed time slice called a quantum. After its turn, it moves to the end of the queue. This makes the system fair and responsive, especially in the time sharing environment.
Finally, the boring part of our video is over. All we have to see now is our code and the demonstration of how the simulation actually works. Let's take a look at it.
Have a short overview of our code. So our CPU scheduling simulator is built using Java programming. We use Swing for graphical user interaction. It can be done by importing these packages as highlighted here. So our program allows users to add processes with process ID, arrival time, burst time, and priority. They are also allowed to choose between FCFS, SJF priority, or round robin scheduling algorithms. So the main class here is CPU scheduler simulator as highlighted here. So this takes care and sets up the GUI, including our input panel as well as the table panel and the Gantt chart panel. The run buttons are also initialized here. So we have our method for calculating the average waiting time as well. As we scroll down, we can see that our main methods are here. The run FCFS, run SJF, run priority, and run RR. As we scroll further, we can see the animation code. So this code mainly focuses on our Gantt chart and how it will appear on our screen. So let's take a look at the demo of our simulation. Now, let's get into how the simulation actually works. First, let's enter all the information that's required of us. Process ID, arrival time, burst time, as well as priority. We will use the same table of information to showcase all the scheduling processes. Firstly, we will start with FCFS. This works on first come, first serve. So as we can see now, the Gantt chart will fill up the processes exactly the way they arrive and lets each process finish fully before moving on to the next one. The waiting time is also immediately visible for us to note down by seeing how the processes carry out. Now we can run the same process again, but this time we set the scheduled process to SJF. Here, the Gantt chart fills up according to which process is the shortest and which arrives first. The waiting time is also visible, which we can note down. Next, we will see priority scheduling. This is why we have the priority column in our table. The processes will run according to which one has the highest priority. In this case, since P1 Or process 1 arrives first at arrival time 0, it runs first, followed by P3, followed by P2. Here it's a lot different from the other two. Lastly, we will run the simulation through round-robin scheduling process. We have set the time quantum as 2 in our code itself, so that is how it will carry out the process, using time quantum as 2. As we can see, this one too is a lot different from the other three. The processes are carried out in time quantums of 2, and it goes on until all of the processes are successfully executed. With this, we conclude our video about the 4 highly important scheduling processes, and we hope that was useful in visualizing how these processes are carried out internally in our operating systems and are finished. Thank you.